In this lesson, we're going to be using the tangent ratio that we defined in the previous lesson to determine a missing side length. So just a quick review, last lesson, if you want to go back and watch it, we defined the tangent ratio and then used it to determine a missing angle. So this time we're going to be using the same ratio to determine a missing side length. A couple of things to review. We're always talking about a specific angle here. So let's say we're talking about angle A. So I'm just highlighting it in the diagram. Then the tangent ratio of angle A is the side length that is opposite to A. So opposite meaning directly across from the angle, divided by the side length that is adjacent to angle A. Adjacent meaning the side length that is right next to, but not the hypotenuse, angle A. And so this time we're going to be given angle A and one of the side lengths, and we will use algebra to solve for the other side length. Okay, so let's look at an example here. So this question says, determine the length AB to the nearest tenth of a centimeter. So first we're going to talk about how our side lengths are labeled here. So when it says AB, it means just the distance from A to B. So this distance here is what we're determining. I'm going to just label this X so that I can use it in my equation. Okay, so let's do some labeling of this triangle. We are talking about, or we are given angle C here. So that's going to be the angle that we focus on. I'm just going to highlight it in yellow. So everything is going to be in relation to angle C. So when I label my triangle, I'm going to look at angle C, and the side that is directly across from it is going to be my opposite side. And then the side that's right next to the angle C is going to be my adjacent side. We haven't been labeling the hypotenuse so far, but I'll just put it on here just for completeness. Hypotenuse. The hypotenuse is always the one that's directly across from the right angle. Okay, so let's, I'll also just highlight so that it matches the definition above. So we have our adjacent side and our opposite side, which we don't know. Okay, so let's write down our tangent ratio. So the tangent of angle C is the opposite side divided by the adjacent. So for us, we're going to put where C is, we're going to actually put the measure of the angle. So we're going to put 30 degrees. And then the opposite side, we don't know that. So we're just going to put X. And then the adjacent side, we do know the length, so it's 10 centimeters. Okay, so I'm just going to highlight everything so that it matches. So that was our adjacent side. The opposite side we don't know, we labeled it X. And then the angle we do have the measure of, so we replaced it with 30 degrees. Okay, so now we're just going to solve for X. So just as a reminder, in algebra, when you're looking for an unknown, you can do opposite operations to both sides of the equation to solve for that unknown. So here, the X that we want to find is being divided by 10 centimeters. So on both sides, I'm going to do the opposite of dividing by 10, which is simply to multiply both sides by 10. As long as I do something to both sides of the equation, I'm not changing the equation at all. So here I'm dividing by 10 and then multiplying by 10, it just cancels that 10 out on the right hand side. And on the left hand side, I have 10 centimeters times tan of 30. And that's going to equal to X. So that's what I'm going to type into my calculator. X equals 10 centimeters times tan of 30 degrees. So this time I'm using the regular tangent button. I'm not using the inverse tangent button. So I'm just going to clear everything out. Now for my calculator, I have to type in 30 degrees first, and then I press tangent. Some calculators you go in the opposite order, so it just depends. So there's my tan of 30 degrees, and I'm going to multiply this by 10 centimeters. And press equal, and I get 5.77, etc. It says round to the nearest tenth, so it's about 5.8 centimeters. So I'm finally going to write equals 5.8 centimeters. Okay, and make sure you have the correct unit. So we're doing a unit of length here, and the other unit of length is in centimeters, so this is going to be in centimeters also. Okay, and there we go. So essentially we set up the ratio, and then you use algebra opposite operations to isolate x and solve for it. Okay, so the next one here, if you want to try it on your own, you can, or you can do it with me. This one is going to be a little bit different because this time we're going to be, the x is going to be in the denominator of the fraction. So the way that we solve is a little bit different. Okay, so let's look at this question here. It says determine the length of EF. So from E to F, I'm just going to label that with an X. Okay, so we want to find that length. We have this angle here, angle F is given to us, it's 20 degrees. And the opposite, actually I'm just going to see, yeah, the opposite I colored in blue. So we don't know the adjacent this time, but we do know the opposite is 3.5 centimeters. So let's give those some labels. So this side is opposite. This side is the adjacent, it's right next to the angle. And this side is the hypotenuse. You'll find in the next lesson we start using the hypotenuse, but for now we're just focusing on the tangent ratio, which is opposite divided by adjacent. So I'm going to go ahead and just write the whole equation down. So the tangent of angle F, which is 20 degrees, I'm going to replace that right away, is the opposite side, so 3.5 centimeters divided by the adjacent side, which we don't know the length of. And then we're going to use opposite operations again. Another way to think of this is doing cross multiplication, but essentially we're going to multiply both sides by x, because x is in the denominator here, we can't directly solve for it, so we're going to get it into the numerator of the other side. So we're going to multiply both sides by x and then divide by tan of 20. Essentially these two just switch places. So it's x equals 3.5 centimeters divided by tan of 20 degrees. So again, the reason why that works is essentially we multiplied both sides by x here. That canceled the x's out. And then we divided both sides by tan of 20 degrees. And that canceled that out. Oops. So when the x is in the denominator, you want to do this little trick where essentially they just switch places, the x and the tan of 20. But the reason that works is because we did opposite operations to isolate the x. Okay, so this time I'm going to type into my calculator 3.5 divided by, and then I'm going to type 20, and then I'm going to press 10 and press equals. So it's 3.5 divided by tan of 20 degrees, and you get 9.6 approximately centimeters. So the length of that missing side there is about 9.6 centimeters. I'm going to label that here. Don't forget your units. And we're not using an equal sign either here. We're using this little squiggly, which means we've rounded our answer. So it's an approximate answer. Okay, that's the end of the lesson.